All right, getting after it. Now they get a little bit bigger. Even after the last one's like, I can't believe it. Yeah, they got bigger. So here we go. I'm going to take my denominator, which are the same. I'm going to go ahead and factor it. That means I'm going to take out a 3n squared. I'm left with n squared minus 4n plus 3. And yes, I realize that can be factored again. I'm going to go ahead and work on this way with this. So when I continue to factor it, 3n squared's out. You get n minus 3 and n minus 1. Because what two numbers multiply to 3 and add up to negative 4? Well, 3 and 1, but they both have to be negative. That's where I got these two numbers from. All right, now at the top, I have 3n plus 4, and I'm adding, this is from right here, adding, so no parentheses, no nothing, n plus 3. So I get 4n plus 7. All right, now does anything factor? No. Does anything go away? No. So we're done. 1 down, 7 to go. Next up top, we're still adding. So this is 3r plus 4 plus r minus 4. That's my numerator, which becomes 4r, and that's it. Interesting, because the 4's go away here. Now, if I'm factoring out my denominator, I'm going to take out a 4r. Ooh, okay. And I'm left with r squared plus r minus 12? Yeah, 12. So I can keep factoring. What two numbers multiply to a negative 12 and add up to 1? That's negative 4 and 3, I believe. No, it's positive 4 and negative 3. Silly rabbit. So then this is going to be r plus 4 and r minus 3. Now, the 4 r's go away. Hey, something went away. That's great. Up top, that doesn't mean we're left with 0. It means we're left with 1. Okay? The bottom is still going to be r plus 4 and r minus 3. All right? 2 down, 6 to go. Next up, I'm adding up top. I get 3 plus 4a minus 2. The bottom just is already factored. 2a minus 1, a minus 3. So up top, this is what we end up having. 4a, because it stands alone, plus 1 over 2a minus 1 and a minus 3. Nothing goes away, unfortunately. If this were a 2 right here, we would, but it's not, so we can't. All right, 3 down, 5 to go. Then, my denominator is already factored for us. Why not? So 2x squared, and then x minus 3, quantity squared. So up top, I have 4x minus 3 and plus 4. Okay. Now up top, that means I have 4x plus 1. Now my denominator is still 2x squared, and then x minus 3 quantity squared. Nothing goes away. So that's it. Done. Not too bad. Then, here we go. I like this problem. Starting subtraction, we have n plus 1 minus 3 on top. Our bottom's already factored. N minus 2 and n plus 1. So this will be n minus 2 on top. And then in bottom, I have n minus 2 and n plus 1. So the n minus 2's go away. They match up. So I'm left with 1 over n plus 1. Awesome. I like it when they go away like that. All right, next up, top, we're subtracting. So I have x minus 2 minus this whole thing, x plus 4. It's all over 4. Then I have x minus 3 quantity squared. So up top, I'm going to simplify this a little bit, distribute the negative, that is. I still have x minus 2, but now I have minus x and then minus 4. This is all over 4, parentheses, x minus 3, quantity squared. X minus x is 0. That goes away. And so I'm left with negative 6 up top. The bottom still 4, parentheses, x minus 3, quantity squared. Now, these two are both divisible by 2. So my final solution, my simplified rational expression, is negative 3 over 2, parentheses, x minus 3 squared. Okay? And that's that. 2 left. Let's see if anything goes away. I have my k's. All right, so k plus 2 minus this. K minus 1. It's all over. Now I'm going to factor this. 2 numbers multiplied 9, add up to 6. That's 3 and 3. Or you could use perfect square trinomial. Either way, what we get is k plus 3 and k plus 3. So This is k plus 2 minus k, and then plus 1, because we're distributing here. It's all over, I'm just going to write this, k plus 3 quantity squared. So now, k minus k, those are 0. It goes away. What's 2 plus 1? It's 3. So I get 3 over k plus 3 quantity squared. That's it. That's all you have. Done. One more. All right, so this is going to be x minus 4 minus 3x all over. Now I'm going to go ahead and take out a 12 on this one. When you take out a 12, you're left with x squared. Oh, I can't take out a 12. What am I doing? Come on. So when you take out a 12, not a 12, a 4, yeah, take out a 4. You're left with 3x squared minus 5x minus 12. Okay, that makes a little bit more sense. Now, that could continue to factor. We don't know. So let's do 3 and the 1, and then this would be 2 and the 6, 4 and the 3. So we're trying to get 5 out of this. Oh, I got it. 3 times 3 is 9. 1 times 4 is 4. I need that to be negative, so that's going to be negative. So if I continue factoring, these are my x's. Can't forget about them, even though you want to. My 3x pairs up with the negative 3. My 1x pairs up with the positive 4. So that gives me my 4x. This gives me my negative 9x. And that's how I got my negative 5x there. So my denominator is 4 parentheses. 3x plus 4. And then x minus 3. Now, still have to go ahead and subtract here. X minus 3x is negative 2x. There's still a minus 4 there. And this is all over 4 parentheses. 3x plus 4 and x minus 3. It's a good thing we did that because now, up top, I can factor out a negative 2. If there's a negative to start with, take out a negative. Take out that negative 2, you're left with x plus 2. Don't forget, if I divide negative 2x minus 4 by negative 2, that's where the positive 2 comes from. This is still all over 4 parentheses, 3x plus 4 and x minus 3. So now those two go away, or not go away, they're divided by 2. I have a negative 1 outside my x plus 2. This 4 right here becomes a 2. I have 3x plus 4, x minus 3. And that, ladies and gentlemen, is that.